and welcome to another episode of Conf42Cast. My name is Miko Pawlikowski, and today my guest, Ian Eyberg, the CEO at NanoVMs. Hello, Ian. How are you doing today?
Hey, everybody. Doing good. Thanks for having us on the show.
And today we'll be talking Unikernels, and Unikernels to give you a little reference. But before all of that, Ian, what's your most favorite thing about space travel?
Rockets are kind of like bombs with a hole in them. So God bless Elon Musk, but I just don't think that's going to happen for our travels to Europa and Mars and Pluto. Okay. That's my opinion.
So is that the fact that they blow up continuously? It's
just a very inefficient, very dangerous way of traveling. I think there needs to be a completely different method of travel if we're actually going to go anywhere and do anything. I suppose it can kind of get you off planet, but that's about it. There's this company called JP Aerospace over in Nevada, which is over the border from California, and they have this thing called floating to space. And what they do is they create these blimps, if you will, and it goes all the way up to the edge of space, like 70, 80 K up. And then you can launch a rocket. And so you get rid of all the drag of the Earth. And I always thought that was a much more sane method to get there. And it's way cheaper too. So there's that.
Okay, well, hopefully you're listening, Elon. You're doing it wrong. So I bumped into Ian recently when I was researching Unikernels and trying to see where they went, because they were all the rage about 2015, 2016, and then I was expecting to hear a lot about them, but I wasn't. So we've got an expert with us today, the CEO of NanoVMs, who has been pushing that. Ian, what's a Unikernel? Let's start with that.
I guess it's important to note that there's well over 10 different Unikernel implementations out there today. And so every single one has a little bit of a different take. But, at least from our point of view, what they really are is a way of provisioning a single application, like one and only one application, as a virtual machine. And it's really just focused on doing that one, the program. So there's no concept of all this other stuff that comes with a general purpose operating system. Generally speaking, not just us, but all the other Unikernels will say that they're a lot faster, a lot safer, with varying degrees of precision on both of those claims. And then one thing that we've noticed with our own users is just the simplicity benefits that come with them versus something like a Kates or something like that. But yeah, that's what it is in a nutshell. It's another way to deploy a Linux application without Linux, and just making it run faster and safer.
Okay, so some people actually call it library operating systems, right? Because you basically, I think it might be worth for the benefit of the audience. I saw this repeatedly being commented. It's like, why would I spin a new kernel for every application that I do want to start, right? So I think it's probably worth emphasizing that the whole idea is that you only put the bits that you need inside of that kernel, right? Is that correct?
Right. Yeah, and to address that kind of question right off the bat, one of the reasons you would do that is because of security. Compared and contrasting to, say, containers and so forth. Containers share a kernel, and that's honestly one of their number one security issues is because of that. If you root one container, you basically have root over all the other containers. And in Kubernetes, that just gets exasperated because Kubernetes spans multiple servers. And so now it's not just one server that you have control over, it's all those servers. So that's actually a really strong security argument for having the kernel. But the other thing that I think why people ask this question is it comes from kind of a misunderstanding on how these things actually get deployed. A lot of people think you're going to Amazon, you're spinning up a Linux, you use something like Ops, and then you run all your Unikernels inside. And yeah, that does sound like a lot of extra crap that you have to deal with. But that's not what we do. What we do is we take your application and create a new EC2 image out of it. A new AMI is built on every single deploy. And when that spins up, that's all it's running. So I think that question is a very common point of confusion that people have on how these things are actually deployed.
Okay, so let's bounce back to this security question, because I've seen it listed on pretty much every one of these kernels. I understand that the primary reason why, for this argument is that the reduced attack surface is basically removing the code that you don't need, right? That makes it more secure by definition. The counter argument to that is that for something like Linux kernel, it's a pretty popular piece of software that a lot of people run. And so when the bugs are being found, they're fixed reasonably quickly. And there's a good chance that if you're running, a reasonably recent version of the kernel, someone has bumped into that and fixed that. With a Unikernel, on the other hand, that means that we're kind of throwing all of that away, right? And we're starting something new from scratch, right? So how do you make people feel a little bit better, I guess, about that aspect of security?
Yeah, no, and that's actually a very fair criticism. Out of all the different criticisms that one could have, that's actually very fair. This code is brand new. Why should I trust this code over code that's 30 years old? That's totally fair. What I would say is, if you look at a lot of the other stuff out there that talks about unikernel security, they're always talking about attack surface, attack surface, attack surface. To me, coming from the security industry, I could care less about that. Yeah, you can mathematically say for every 1,000 lines of code, you're going to find one bug or two bugs or whatever it is. But I really could care less about that. For me, it's really about the single process nature of unikernels. And that is the whole idea of an attacker breaking your software, breaking into your server. The whole impetus for them to do that is to run their code on your server. They really could care less about your code. That's just like the entryway to the house that they're breaking in. Once they're in your server, they want to run MySQL dump, or they want to install a crypto miner, or any number of other programs, and unikernels just explicitly prohibit that in the general case. That to me is like the bigger security benefit of running unikernels. Is it just raises that bar up so much higher, because it doesn't really deal with the vulnerabilities that exist. Those are always going to exist. They get created every day because that's what we do as software developers. But they do deal with exploit payload mitigation. That's to me the biggest benefit.
Yeah, definitely. A whole class or a few classes of potential threats are automatically eliminated.
Yep.
Which can be definitely a worthy trade-off. You said another thing, quicker or faster, the performance aspect. So can we talk about the performance aspect a little bit? Because when I was looking at it, one of the arguments for a unikernel was this extra bit of performance that you don't spend time between changing context between kernel and user space. Mm-hmm. But you guys are not actually doing that, right?
Yeah, let's dive into that, because another point of confusion. So when we talk about context switching, it's important to realize what context you're talking about. There can be various levels of switching depending on what you're talking about. It can be a user process to user process. It could be a kernel thread to kernel thread. It could be a kernel to user. There's a couple different cases, and they all have different performance costs associated with them. I think a lot of the earlier literature in unikernels really did focus on that kernel to user land context switch, because there is a cost associated with it. Microsoft themselves have measured it to be 30% tax. So it's a well-known cost, and it's something that developers have just ate forever, right? But in our own investigations, what we think real tax is the multi-process context switching in the case of your typical Linux VM. So if I go to Amazon or Google, I spin up a Ubuntu instance, there's about 100 different programs running already on that instance without me installing a single thing. Now, that's true even if you're using a T2 Nano or whatever it is, where you have one vCPU, you can say that's one thread. If you have 100 programs all fighting over that one thread, you're going to have massive waste. And a lot of people just don't think about it, because they can't really, unless they're using tools to measure it, they don't even see it, because that context switching is happening so fast, they don't really see it. But there's a real performance cost. And so, in our view, the kernel user land stuff is not as horrible as the full process to process, where you're fleshing out the TLB and doing all that other stuff. The reason we kept that, this might answer a follow-up question, so why do we, nanos.org, why does our project keep that distinction? And the reason is because of page permissions. So if everything is running in that same context, that means I can use certain instructions to basically change the permissions for various pages. So whatever your kernel is doing, I can just say, hey, I'm going to overwrite that entire chunk of memory, make it writable, and then I'm going to make it executable, and then I can do whatever the hell I want as an attacker. That's a major, major security issue, and none of the other unikernel implementations out there I'm aware of have come up with a way to kind of deal with that. And so anyways, coming from the security world, that's one reason why we have that. But we still, just to address the performance, we can still run things like Go and Rust web servers 200% faster on Google, 300% faster on Amazon, as measured in like requests per second, for instance. So there's still plenty of performance advantages to be gained simply by moving to this model.
Okay, so this is very interesting to me, and I'm kind of glad that you threw in some numbers. So is what you're saying that the bulk of the 200 or 300% increase in speed that you mentioned coming from the single process model?
Yeah, so just to be more clear on that, Nanos is a single process, but allows multiple threads. So if you go to Google, and right. I think the largest instance you can spin up with the number of threads is like 384, 386 threads. If you have a program that can deal with that intelligently, you can scale as vertically as you want. Now, a lot of languages like your Node, your Ruby, your Python, any of the interpreted languages, those are all single process, single thread to begin with. And so, back in the day, but people are probably doing this today. If I want to scale a Ruby application, I might have Nginx in front, and then we have like 5 or 6 workers behind it. It's the same thing in unikernel land, except those workers become individual VMs instead. So you're still doing the exact same sort of horizontal scaling in languages like that, because those languages are just the way they're made, they're inherently kind of stuck in that paradigm. Keep in mind that a lot of these interpreted languages are just as old as Linux, right? They're from the 90s. So there's certain constraints of that time period, which is why they exhibit some of this behavior. And I think it's really great that we have newer languages like Go and Rust and languages like that are really starting to embrace the multi-core future that we're in. I mean, it's only going to grow from here. We're way past scaling CPU frequencies, way past that. So it's time that developers really need to start embracing it, whether they want to or not.
So that actually makes me think of two things, and forgive me if they're naive, just kind of try to explain to me like to a 5-year-old. So
sure.
First of all, would you not be able to get some of that same benefit if you just did some CPU pinning for your processes running on Linux? And second is that you rely on the hypervisor, and it looks like most of the time you're going to be running on something like KVM. So under the hood, you're still going to have the process that's being switched between CPUs. And that process is going to implement your VM, right? So some of that cost, you can't really escape it anyway, unless I'm, not deep enough in the understanding of that.
Yeah, so I'll address that second question first with the hypervisor. Nanos, and pretty much many of the other unikernel implementations out there, they're not built to run on bare metal. A lot of people have this idea that I'm going to go flash on Raspberry Pi with my unikernel, and that's what it's built for. Right. I think that's a very, very, very niche use case. I don't know anybody outside academia that is doing that. That's, when we run Nanos on, say, an RPi 4, we're still using a hypervisor. Why? Well, in the future, like already you can get an RPi with 4 threads, and now it's going to be like 8 threads here soon. That hardware is going to continue to progress. And it just doesn't make any sense to take over the entire server. But we're always running as a VM at the end of the day. There's never a case where we're installing to bare metal. And so that hypervisor tax or whatever, that's always present. And it boggles my mind, but there's a lot of people out there that don't realize that the entire public cloud is completely built on virtualization. Like every single public cloud is entirely 100% virtualized. Amazon, Google, Azure, it's all virtualized. And so if you're deploying to your public cloud, you are already sitting on a hypervisor. Unikernels embrace that by deploying and using those native cloud facilities. So the cloud native community can say, oh, we're cloud native, and unikernels can be like, well, we're like hyper cloud native because they're almost even a layer below. As for your CPU pinning question, Yeah, you can pin to CPUs and so forth as well. But again, a unikernel being single process versus something like Ubuntu server or Debian server, there's just so much more stuff on there that is going to fight over those threads. So if you have 24 threads, great. But if you have like one or two, I mean, you're going to have some performance taxes. And so, we get asked all the time, well, isn't it just like Alpine Linux and, set comp applied on it? And the answer is no. Even Alpine, whether it has a small file system or just a handful of programs, it's still Linux at the end of the day. And what I mean by that is it still has the concept of users. It still has the concept of multiple processes. It has shared memory. It has all these concepts that belong in that multiple user, multiple process world, a world that was invented in 1969, 50 years ago. For computers that took up entire walls. That's not the world that we live in today. Even back in 91, when Linus produced Linux, we were working on 386s and 486s. Okay. So we still didn't have SMP processors. Those didn't really arrive in a, commodity form until 2000. That means we didn't have real threads in Linux until like 2001 when NLTP came along. We didn't have virtualization in a commercialized form until Citrix and VMware came out again in the 2000s. It was still a solid 10 years before we could even really do something. Going back to what you were talking about, library operating systems, that was a concept of the 90s, but they couldn't really embrace that because threads, SMP, virtualization, none of that had really been produced to the market yet. And those were the three kind of horsemen, if you will, that really kind of allowed this technology to take place. So it's kind of a function of the technology and where it was at the time.
So we keep touching upon the kind of lightweightness nature of this unikernels. And I think a lot of the criticisms that they do get is around, okay, so that's really cool, but how do I debug it? I don't get my favorite tools. I don't get my, usual stuff that I typically get. And doesn't that make it harder to, for example, know that I've been breached if there is nothing in that VM that actually keeps any trace of that? How do you address that? And what's the latest in kind of making it better and helping people to potentially make the transition between a standard Linux kind of environment and the unikernel?
I think there's a handful of questions in there. One is just general, how do I debug these things? So one thing that should be pointed out, and this is honestly something I could mention, but it's just going to fly over people's heads until they try it out, until they deploy their first unikernel. But these things are not like Linux. And it's just something that until you deploy your first unikernel, you're not going to understand fully. When I say they're running a single application, one and only one application, that's literally what it is. So if you wanted to SSH into your Debian server, that's not the same thing as like SSHing into your application. If I have a Node.js application, I don't like SSH into it to do random tasks with it. I might instrument it so I can collect GC information, collect memory growth over time. I might ship out logs via syslog, so it goes to Elasticsearch or Splunk or something like that. But the whole concept of popping into an instance and trying to debug the actual server versus your application, that's kind of this head change that people have to get around, and they have to realize that no, it's really just your application. Let me give you some examples. Let me throw on my DevOps hat. I have a server that PagerDuty just blew up my phone on. So I'm SSHing in and, oh, well, actually, I can't even SSH in because the disk is full. Why? Well, turns out the disk was full because nobody set up log rotation for, some cron job that was going on. And that's like one example. Another example would be I pop in and something's opening up 1,000 different connections in span of a minute. And I'm like, well, which process is doing this? So I whip out ls off and I try to figure out which process is opening up all these connections. All these different examples that I bring up, they always come down to the fact that I never really know which program is actually causing the issue to begin with. In unikernel land, you already know because there's only one program. And so then, once I isolate the program, what do? Well, I would go offline and try to reproduce the problem, right? The whole debug and production thing is something that unikernel culture, if you will just kind of frowns upon. Most DevOps and SRE people aren't going to be able to just whip out a patch for whatever program that they're looking at anyway. They're going to try to mitigate around the problem. That's one of those things there. But suppose you do want to debug, like we have explicit instructions to attach GDB to it and start poking around. You can instrument it with Prometheus. All the instrumentation stuff works. All the APM stuff works. We actually wrote a custom APM agent specifically because there were a few unique things that we found we could do with unikernels. I'll give you a case example. The database that actually backs that thing would crash quite a bit because we were still working out some issues. And so what we could do is we could take a snapshot of the entire VM that runs on Google and then export it as a disk image, download it and run it locally and pinpoint the exact line where it was crashing. You can't really do that with a Linux VM because there's all this other stuff running inside of it, right? But with unikernel, since it's only that one application, it becomes trivial to figure out what's going on. So yeah, there's lots of different ways of debugging these things. And I would just also end with the fact that asking that question is kind of asking like, how do I debug a Heroku app? Or how do I debug a serverless app? Or in some areas, how would I debug a container running in some hosted K8s environment? It's all the same sort of question. And, there's different ways of doing these tasks in these different environments.
Yeah, and I think it kind of goes back to the mental model shift that you were describing, because for me, when I was looking at it back a few weeks ago, I was like, oh no, I'm not going to have my eBPF, and I like my eBPF. So what's like the equivalent visibility onto the lower level stuff of the kernel functionality that you built into the image that would be comparable to something that you can do with eBPF today? Is that something you're actively, trying to provide for?
So there's a couple of different things, right? Things like strace and ftrace, we actually have almost direct equivalents for. So if you need to go profile something and produce a flame graph, we use these tools internally just to hunt down things. So there's equivalents there. Equivalents can be written. In terms of one way to kind of twist this question is what tools can I use interactively in production versus a dev test environment? And what we would say is instrument the stuff that you care about. And if you truly are trying to, quote, debug something, then that should probably be done locally to begin with. But yeah, a lot of these tools exist. Like I said, the strace, the ftrace, and all this other stuff.
What about the networking stuff, the stack? What visibility do you get out of the box if you go, for example, with NanoOS?
Yeah, so networking is the same thing. So, networking is, and this is something good to touch on, coming from a container Kubernetes environment, those environments duplicate the network stack, they duplicate the storage stack. This is what actually slows them down compared to, say, a normal native Linux. And so there's lots of different ways to shoot yourself in the foot, but there's also lots of different ways you can kind of expand and do various things. A lot of those tools still exist, right? In some cases, the clouds aren't going to allow you to set up promiscuous mode and start sniffing the traffic for security reasons. But if you have your own stack, your own servers, you can totally do that. We operate at that same sort of layer. Locally, if you run ops, you might use user mode in a dev environment. And prod, Google's going to spin up a tap interface. They don't call it a tap interface, right? They call it here's my elastic network adapter or whatever. But under the covers, that's what's going on. So it really depends on where you're deploying to and what you're interfacing with. Not sure if that answered the question or...
No, it does. Obviously it kind of sounds scary to be like, oh, I've really grown to like those tools now, and switching to anything else sounds like jumping a little bit into the unknown, but that's what progress always looks like at the beginning anyway. So I think we kind of covered all my notes of the really more popular kind of criticism that I've been hearing about them. One that we maybe haven't touched on directly is that a lot of people just say that containers and micro VMs or things like gvisor, if you want to be a bit more exotic, they kind of give you a lot of these benefits that a unikernel provides without having to actually change the environment and having to recompile the kernel every time. How would you address that
Again, a couple of questions here. I'll start with that very last one, recompiling. So again, being very different than some of the other implementations out there, we don't recompile your application. We think that's basically a non-starter, in our opinion, for most people. There's a lot of software that people use that they don't necessarily write themselves. So that's a huge ask for many people. I mean, a lot of people look at why Docker exploded to begin with. Sudo apt-get installing and editing some config file was already enough of a pain in the ass for most people. So asking them to recompile from scratch is just not happening. So we don't do that. We load raw elf binaries, and if it runs in the unikernel paradigm, it runs in our system just fine. As for gvisor, Firecracker, we can touch on those really briefly. First off, Firecracker, you can actually run nanos and many other unikernels inside Firecracker. Firecracker is not a competitor to unikernels. It's complementary. So if you need certain guarantees that Firecracker gives you, namely that is faster boot time at the cost of lower runtime, then you can totally use it today. We have tutorials, and so do other unikernels out there. That was really meant for serverless and also fast instantiation. I should point out that if you're going to shove something like, say, a JVM inside Firecracker, it's not going to boot that fast, right? So, you still have the boot time of your app. If you have a Rails app inside Firecracker, that's not what it's for. It just, buyer beware on that sort of thing. gvisor, we can look at that. So gvisor basically addresses the container security argument head on. And it's basically Google saying, hey, we understand containers are not a security primitive at all. And so they offer gvisor. And gvisor Google has this habit of having these projects inside Google. They basically twist the name and completely rewrite it and then release it as open source on the outside. gvisor is one of those projects. gvisor is different though, because what they released, it relies on hardware virtualization to actually perform in a manner that's acceptable. So by hardware virtualization, I'm saying it's using the exact same sort of underlying stuff that unikernels and typical VMs are using at the end of the day. Now, if you're not using that, which is the default case, if you're running it on any of the clouds, it's going to use ptrace. And so anybody who's ever touched ptrace knows that this is going to make it insanely slow. So I don't really understand where gvisor is going in terms of what they're trying to do. I don't know, but ptrace is just kind of a non-starter in my opinion for prod workloads. Containers, obviously, all these companies and everybody's using containers. If people are happy with that, keep going at it. There's a few other projects in the space, but yeah, in general, it's not something we're really competing against technology-wise. I think you had brought up eBPF, and maybe that's worth jumping into a little compare and contrast. That definitely has lots of interesting use cases, like you mentioned, tracing various things that you might be interested in. That, in my opinion, is its main predominant use case. Getting performance characteristics of lots of things, right? But there is a small contingent of developers out there that are kind of arguing that it's going to be some sort of new application runtime. And that, I think, people are so far off on, mainly because they don't know some of the constraints that it has. Things like the no unbounded loops rule. So that's basically saying no do whiles. At first blush, that says, okay, well, I'll just do a for loop and, cap it at whatever. But what you don't understand is that there's lots of other things that prevents. Greedy algorithms that are commonly used in pretty much every standard lib of string libraries. So your strip white space at the end of a string type of things, your regexes, lots of those different things. And where would I use this? Well, practically most applications. So yeah, for reasons like that, I don't see eBPF being this new application runtime. I do see it getting lots and lots of dtrace style like observability into your applications. And that's where its sweet spot is getting that performance profiling now.
Let's switch gears a little bit and help me out. I've been trying to kind of come up with an example of a perfect application for Unikernels, the killer app equivalent. From your experience, you've been at it for quite a few years now. What is, the most attractive use case for Unikernels that people actually do today?
I mean, and I'll just preface by saying that I don't really believe in the whole killer app thing anyways, because all the technologies we talked about, for instance, none of them have killer apps, right? they have users that are deploying normal software for them. But yeah, in terms of like the end users and customers that we have, and like what do they actually use this for? It's all web app software. So it's all web apps that they might be deploying to any number of cloud systems today. If they're writing Go and they're deploying to Google, if they're writing Rust and they're deploying to Amazon, you name it. I mean, the public cloud ecosystem and all the software that resides on it is absolutely massive, in terms of scale. And what's really funny is that actually only really represents like 3 to 5% of North American compute to begin with, which is kind of a mind-boggling statistic. But that's both something that Urs, the head of Google Cloud, has mentioned, and both Diane Green, who was the ex-CEO of VMware. So any software that you'd be deploying to a Linux VM in the cloud today is kind of what we target. And that's what people are using it for right now. I think the most popular workloads are probably Rust, and then Go probably being a second. But we don't track anything. We don't have any kind of phone home telemetry included by design. The only data we have are from customers that we interact with. And then the package repository, we've added some lightweight download counts and stuff like that too.
Ian, how did you get into Unikernels?
Good question. Just to preface, we did not invent this, right? I was reading a lot of the papers that were coming out of, the Mirage crew, which is later on they formed Unikernel Systems, and then they were acqui-hired by Docker. So at that time in like 2013, 2014, I was reading a lot of their papers, and there's other stuff in the space too, like OSV that was ran by Claudius Systems that kind of pivoted over into SiciliaDB, which is a Cassandra replacement. So just playing around with that stuff and, just getting super, super interested in the ecosystem, and then was wondering why nobody had written a Go Unikernel, which is Go was the language I was using quite a bit at that time. And so we kicked off a project to make Go Rump, which was a Go implementation in Rump Run at that time. And I booted that up on KVM, and I was just like, oh man, this is totally what the future is going to be like. Because it was so painfully clear, again, coming from the security world, that's what initially attracted me was the security implications of it. And then I started seeing the performance, and I started seeing, man, this is, the amount of software that people were diving into, microservices started being a thing around that time. And so all that together just kind of threw me into the vortex of Unikernels.
And at some point that became NanoVMs, the way that...
Yeah. So NanoVMs was actually a different company at one point, and focused on APM type of stuff. And then we started building out infrastructure to kind of host our own apps, and then, started doing all these patches and so forth. And eventually it became kind of clear that to kind of really take it in that direction, we had to write our own kernel. And so I think it was around 2018 was when we started writing Nanos. And just a word of caution to anybody out there that's thinking about doing the same thing. Linux is 30 years old right now. And so it's a shit ton of work to write something that's even halfway decent. Anybody can kick out a Hello World bootloader in half an afternoon. It's pretty easy to do. It's only 512 bytes, right? So it's pretty easy to do. But, add in the networking stack, start supporting many languages, and start doing all this other stuff. And then on top of that, say that you're faster than Linux, say that you're more secure, stuff like that. It's a lot of work. I don't think people understand how much work is actually involved. And so going to some questions, where are Unikernels? Why haven't I heard so much? Blah, blah. What happens is a lot of these implementations, they get initial bit of traction. They might get a grant. They might get a little bit of seed funding or whatever. And then they don't get enough done before they die. And that's literally happened to so many of these organizations out there. I'm not going to name names, but pretty much all of them. So it's that much work. And so, we fought tooth and nail to kind of get resources into the company and carry on the mission for a while now. And so, but we're pretty comfortable where we're at right now, and so we don't think we're gonna meet the same fate.
So did you kind of started knowing, okay, that's going to be a lot of pain, or were you?
I had a fair idea it was going to be some pain, just knowing the amount of work. I don't think I took in how much work, but I understood that there was going to be quite a bit of work involved.
Fair enough. So let's talk a little bit briefly about, kind of like the unique value proposition, because as far as I understand right now from the companies that actually offer a product publicly and are alive, there's you guys, and then there's the Unicraft. I'm not too sure what's the, our kind of company structure behind. And that's about it, right?
There's about 3 others that I would say are alive. I know either have funding or have customers or basically are still working. Put it this way, they have employees and they're actively working on it. There are a handful of others. Again, a lot of these companies have different takes on how to go about dealing with some of these issues. Some of them, it's less about dealing with the issues and more about coming up with some of the benefits. But yeah, Unicraft, I haven't spoken to them personally. I know a lot of them were coming out of NEC, and they have for the past 4 or 5 years been publishing a ton of papers. I mean, that's the other thing. A lot of people are like, "Where's Unikernels? Where's Unikernels?" And it's like, have you looked at any of the conferences? OSDI, Hot Cloud, like all these academic conferences every year. There's like half the conference is Unikernels. So it's if you're wondering where the research is, where motion is, that's where you should check it out. But yeah, they definitely have kind of the more pure approach where they you pick the libraries that you want, it compiles the application, and you're off to the races. We haven't done any like benchmarking or anything against what they're doing yet, but yeah, that's kind of one of the big main differences from them versus what we're doing.
I saw on your website someone wrote a copy, "Run faster than the speed of light." Did you write that?
Yeah, I might have had a beer or something. I don't know. I wouldn't read into that whatsoever. It'll probably be changed in the future. It's not like a official slogan or anything. So.
I was just laughing a little bit. I'm thinking Mr. Einstein is turning in his grave reading that, but
yeah, well, you can't disprove the existence of tachyons, going back to our need for different space travel. So
fair enough. So I just wanted to also touch a little bit because, for us here in Europe, a lot of us picture a garage somewhere in Silicon Valley. What's your founder experience been so far? For something this technical and this, I guess, like you said, painful in a technical way, because, all startups are painful in their own unique ways. What's been your best and worst experience so far, if you were to pick just one of each?
I spoke about how much technical work there is, but that's just one side of the coin. The other point is very few people even know Unikernels exist. It's not like saying, "Oh, we're a database company and nobody knows our database company exists." It's like, no, they don't even know databases exist, type of thing.
Yeah, it's a thing.
So I can walk down the streets of San Francisco, yank somebody with a hoodie on, and saying, "Hey, what's a Unikernel?" And chances are they're going to be like, "What?" So that's a problem, right? If you want to kind of take it to market, there's a lot of developer awareness, developer education. One of the reasons why we're talking on this show, there's a lot of awareness on like getting people to understand that it's an option. That's something we're just now starting to address because there was so much upfront technical work that had to be done. Nobody wants to come check it out if all you can do is some crappy hello world, right? They want something that works, something that not only works, but does what you're claiming it to do. So yeah, that's where we're at. In terms of like the best and the worst, I mean, I would say the worst thing, just from a company perspective, is I'm an engineer by trade, so that's where I come from, and there's just an ungodly amount of random bullshit that you have to deal with that has nothing to do with the tech, has nothing to do with sales, like literally has nothing to do with anything but just like managing the day-to-day of a company. And it's ungodly how much there is of that that you have to deal with. And the sooner I can give that work to somebody else, the better, in my opinion. The best, I would say the best thing is that, you're the captain of your ship, and, your ship can sink in the ocean if you let it. But if you can take that ship and sell wherever you want to go, to me, that's really magical. So, to be able to carve out a system, the way I see it, it's like Linux is literally 30 years old. I've been using it since I was given a handful of 144 floppies, being able to set like an entirely new direction for at least a certain subset of software. That's like super exciting. There's so much opportunity to do, so many things to explore. And, I think anybody in my position has a sort of fountain of ideas going off in their head at any given time. And, it's best to ignore most of that. But that's what creating a new ecosystem allows you to do is, if not you, then you enable everybody else to kind of explore. So.
Do you expect a Docker moment for Unikernels, or do you see it more as a kind of a slowly growing niche for people who really care about one of the advantages? Or maybe a different way of asking this question is, where do you see them in, say, 5 years' time?
I wouldn't say there's going to be a Docker moment quote. What I do see is, our company's going to be around. We have enough customers and enough traction to where we're not going to be dead anytime soon. We're basically self-guiding at the moment, so to speak. We can kind of do whatever the hell we want. There's lots of ways we can go, and at least from the company perspective, it's really kind of going in and just really pounding through. There's so much software out there. A lot of people are like, well, obviously you're going to talk to the most bleeding edge organizations, and we do, but there's software that hasn't been updated in like 30, 40, 50 years. So there's so much software out there that needs help. And so I see lots of opportunity to bridge some very long standing problems in the software world. I keep coming back to the cathedral and the bazaar, not to track that into this conversation, but keep coming back to it because, a lot of people were like, oh, well, open source, changed the narrative there. And, PKH has kind of this opposite view that I share. And he's saying that, he has this paper called The Generation Lost in the Wilderness or something like that. And he argues that open source was kind of dual-edged in that sense where, the bazaar has lots of choices, but there's a lot of crap out there too. Not necessarily arguing for the cathedral approach, but there are lots of problems that we can fix. I mean, I'll give one example, which I give a lot. libxml, libxslt. Those two libraries are linked into every single interpreted language out there. And they're both fairly old. They're like 20, 25 years old. libxml has a FTP server in it for God knows what reason. And I mean, you can find vulnerabilities in it, and just that's the state of our open source ecosystem. Politicians like to talk about bridges and roads falling down and stuff like that, but we have the exact same issue in open source. And Unikernels offer this kind of unique way of coming in and repairing a lot of these bridges. Why? Because we don't have to throw the entire kitchen sink at a given application. Come in and start doing all sorts of other interesting things. People have been talking about like link time optimization and stuff like that for years. Well, in a unikernel system, that's actually something that's feasible. In like a Linux system, that's totally not feasible. There's lots of different things that can be done there when we get an ecosystem that kind of embraces some of this.
Powerful stuff. and some really good examples too. So for anybody who wants to start with nanos, I guess, or what is it, ops that they will be starting with, what's the easiest, what's the recommended path to go and, give it a hello world, despite the fact that...
Yeah, either go to nanos.org, nanos.org, or go to ops.city, ops.city. They both have kind of getting started guides that can get your first hello world up in seconds. And, if you're feeling adventurous, you could be deployed to Google or Amazon or wherever in like minutes. And I would strongly urge like anybody that's interested in it, don't go read other articles. Don't just go look for opinions. Just try stuff out yourself and form your own opinion. And then you can say this is trash or this is awesome, or you can say meh. Form your own opinion by trying it yourself, and it'll answer so many questions you have. It's what I would highly encourage people to do.
Some of the articles being, what was it? Unikernels are going to kill containers in 5 years.
Right.
7 years ago.
Yeah.
And the other one, unikernels are not production grade or something like that.
Yep.
None of which necessarily played out. Okay. If you were barred from saying the word unikernel for about 30 seconds now, what would be any other technology or language or methodology or anything to look out for in 2022?
One ecosystem that is interesting from an engineering standpoint, I wouldn't say it's going to catch fire or anything, but there's a project called FireSim out of Berkeley, and it allows you to simulate exotic hardware on FPGAs running in the cloud. So what does that mean? It means, for instance, when we wanted to add RISC-V support to the Unikernel, how do you even test that? Because there's no RISC-V board that runs KVM today, because they just added the hypervisor, the virtualization spec. They ratified it like last August. So we actually today don't have hardware that can run it under KVM. But you can go to the cloud and you can run a virtual implementation of that hardware. The FireSim people are crazy. They didn't just simulate like one server. They have papers where they talk about simulating an entire rack of servers that don't straight up exist. And I'm not talking about VMs. I'm talking about like chips that don't exist. And to me, that blows my mind, because it opens up the door to, again, exotic hardware that you don't have to go to the fab for. You don't have to spend, millions of dollars to print. You could just try it out in the cloud. And I can't say that that's going to lead to some sort of Cambrian explosion, but it certainly is very, very interesting.
Well, some people call it classic cars. Some people simulate classic hardware. Everybody has their own thing. So I guess the last question for you before I let you off the hook. From your experience, what would be like a single highest return on investment thing that you did for yourself, for your career, anybody can replicate? And it can be anything, anything that you actually found a good return on investment on.
I would say just explore and work on stuff that you feel like doing. I don't want to say follow your passion, because I think that's horrible advice. At some point, especially if you want to run a company, you have to clean a toilet. I do lots of things that I really don't like doing. It just has to be done. But yeah, like if you're doing stuff at your job and you're like, I hate this, go find another job. Or like start your own, or do something else, because it's just a waste of time, So if you're completely bored of computers, maybe jump into a completely different, go explore philosophy or rockets, or I don't know, something else. But computers is pretty deep and wide. So
or not rockets, because they're terrible.
Right. So, but yeah, there's that, and I guess on the tail end of that, just work at it. I'm not saying butt in the seat, clocking hours type of work, but when you're working, work. Don't go to Twitter. Don't go to Hacker News. Don't do all the time wasting stuff. Just work.
And I think that's a really good way to wrap it up. So everybody, Ian Eyberg, CEO at NanoVMs, nanoos.org is where the Unikernel lives, and nanovms.com, if I'm correct, is where you get the commercial support with all of this stuff. It's been a pleasure. Thank you so much. I think I've learned quite a bit about the Unikernels and when they are. Thanks for coming on the show. And I'm telling you already, we're going to get you on in a couple of years' time to see where it went.
All right. Sounds good, man.
Thanks a lot.
Yep. Bye-bye.